Welcome to the Hugging Face task series. In this video, we will take a look at the text summarization task. Summarization is a task of producing a shorter version of a document while preserving the relevant and important information in the document. Summarization models take a document to be summarized and output to summarized text. This task is evaluated on the Rouge score. It is based on the overlap between the produced sequence and the correct sequence. You might see this as Rouge 1, which is the overlap of single tokens, and Rouge 2, the overlap of subsequent token pairs. Rouge n refers to the overlap of n subsequent tokens. Here we see an example of how overlaps take place. An example dataset used for this task is called Extreme Summarization. This dataset contains texts and their summarized versions. You can use summarization models to summarize research papers, which would enable researchers to easily pick papers for their reading list. For more information about the summarization task, check out the Hugging Face course.
क्या है ये रूज स्कोर समझा नहीं 1 और 2 और क्या था?
I think it's a benchmark, right? To
Like
determine
depending on
good
how much is common between the summarized text and the original text.
yeah. So how much of again let's वो उसका intro था, but from
हाँ.
what I could gather, like how do you know summary was good? Like how much of the words from
That's very like qualitative, right?
right. So how do you
Number
benchmark something? How would a machine benchmark something that it is a good summary? Right. Then it probably looks for some overlap जिसका uncommon words generally corpus में है, उसका समरी में ओरिजिनल डॉक्यूमेंट्स में ओवरलैप ज़्यादा है, राइट? मतलब ऐसा सिर्फ ओवरलैप होने से भी काम नहीं चलेगा. इन द दे ऐसे कॉमन शब्द ओवरलैप होने से कोई मतलब भी नहीं है, राइट? तो कि कौन से चीज़ का ओवरलैप है, कौन सी चीज़ का नहीं ओवरलैप, और नहीं ओवरलैप से क्या मतलब है वो होपफुली डिटेल में पता चलेगा. बट आई गेस सम सॉर्ट ऑफ अ बेंचमार्क. Let's go through all 3 videos. उसका वैसे टेक्स्ट ज़्यादा बेहतर है, but we'll come
Let's
to
see how to preprocess a dataset for summarization. This is a task of, well, summarizing a long document. This video will focus on how to preprocess your dataset once you
Volume बहुत कम आ रहा है.
नहीं, वो कम ही बोल रहा है. मैंने फुल मैक्सिमम किया मेरे कंप्यूटर को. मुझे भी कम आ रहा है, मतलब.
one column for the long documents and one for the summaries. Let's see how to preprocess a dataset for summarization. This is a task of, well, summarizing a long document. This video will focus on how to preprocess your dataset once you've managed to put it in the following format. One column for the long documents and one for the summaries. Here is how we can achieve this with the datasets library and the XSUM dataset. As long as you manage to have your data look like this, you should be able to follow the same steps. For once, our labels are not integers corresponding to some classes, but plain text. All of us need to tokenize them, like our inputs. There is a small trap there, though, as we need to tokenize our targets inside the AsTargetTokenizer context manager. This is because the special tokens we add might be slightly different for the inputs and the target, so the tokenizer has to know which one it is processing. Processing the whole dataset is then super easy with the map function. Since the summaries are usually much shorter than the documents, you should definitely pick different maximum lengths for the inputs and targets. You can choose to pad at this stage to that maximum length by setting padding equal max length. Here we'll show you how to pad dynamically, as it requires one more step. Your inputs and targets are all sentences of various lengths. We'll pad the inputs and targets separately, as the maximum lengths of the inputs and targets are completely different. Then we pad the inputs to the maximum length among the inputs, and same for the target. We pad the inputs with the pad token and the targets with the -100 index to make sure they are not taken into account in the loss computation. The transformers library provides us with a data collector to do this all automatically. You can then pass it to the trainer with the datasets, or use it in the 2TF dataset method before using model.fit on your Keras model.
ये देखा रोग मैट्रिक आ गया तेरा अरे बाप
What is the Rouge metric? For many NLP tasks, we can use common metrics like accuracy or F1 score. But what do you do when you want to measure something like the quality of a summary from a model like T5? In this video, we'll take a look at a widely used metric for text summarization called Rouge. There are actually several variants of Rouge, but the basic idea behind all of them is to assign a single numerical score to a summary that tells us how good it is compared to one or more reference summaries. In this example, we have a book review that has been summarized by some model. If we compare the generated summary to some reference human summaries, we can see that the model is actually pretty good and only differs by a word or two. So how can we measure the quality of a generated summary in an automatic way? The approach that Rouge takes is to compare the n-grams of the generated summary to the n-grams of the references. An n-gram is just a fancy way of saying a chunk of n words. So let's start with unigrams, which correspond to the individual words in a sentence. In this example, you can see that 6 of the words in the generated summary are also found in one of the reference summaries. And the Rouge metric that compares unigrams is called Rouge1. Now that we've found our matches, one way to assign a score to the summary is to compute the recall of the unigrams. This means we just count the number of matching words in the generated and reference summaries and normalize the count by dividing by the number of words in the reference. In this example, we found 6 matching words and our reference has 6 words, so our unigram recall is perfect. This means that all of the words in the reference summary have been produced in the generated one. Now, perfect recall sounds great, but imagine if our generated summary had been something like, I really loved reading The Hunger Games. This would also have perfect recall, but is arguably a worse summary since it is verbose. To deal with these scenarios, we can also compute precision, which in the Rouge context measures how much of the generated summary was relevant. In practice, both precision and recall are usually computed and then the F1 score is reported. Now, we can change the granularity of the comparison by comparing bigrams instead of unigrams. With bigrams, we chunk the sentence into pairs of consecutive words and then count how many pairs in the generated summary are present in the reference one. This gives us Rouge 2 precision and recall, which as we can see is lower than the Rouge 1 scores from earlier. Now, if the summaries are long, the Rouge 2 scores will generally be small because there are fewer bigrams to match. And this is also true for abstractor summarization, so both Rouge 1 and Rouge 2 scores are usually reported. The last Rouge variant we'll discuss is Rouge L. Rouge L doesn't compare n-grams, but instead treats each summary as a sequence of words and then looks for the longest common subsequence, or LCS. A subsequence is a sequence that appears in the same relative order, but not necessarily contiguous. So in this example, I loved reading The Hunger Games is the longest common subsequence between the two summaries. And the main advantage of Rouge L over Rouge 1 or Rouge 2 is that it doesn't depend on consecutive n-gram matches, and so it tends to capture sentence structure much more accurately. Now, to compute Rouge scores in the datasets library is very simple. You just use the load metric function, provide your model summaries along with the references, and you're good to go. The output from the calculation contains a lot of information. The first thing we can see is that the confidence intervals of each Rouge score are provided in the low, mid, and high fields. This is really useful if you want to know the spread of your Rouge scores when comparing 2 or more models. The second thing to notice is that we have 4 types of Rouge score. We've already seen Rouge 1, Rouge 2, and Rouge L, so what is Rouge L sum? Well, the sum in Rouge L sum refers to the fact that this metric is computed over a whole summary, while Rouge L is computed as the average over individual sentences.
I think a lot of this stuff will not be needed anymore per se with LLMs, right?
वापस बोलना, थोड़ी मेरा आवाज़ इसमें यहाँ पे मैंने एडजस्ट कर रहा था.
A lot of this stuff
Uh-huh.
will not be needed anymore with LLMs because this is basically going on the premise that you have words which are same as the original text, right? Some words and grammatically correct, so to speak. But LLMs can generate something which has not a single word from the original text, but it still means the same. So and it could still be a very good summary. So this is a sort of rudimentary method of measuring how good your summary is. I don't think.
Why do you say? I am not sure I understood. तो क्या बोल रहा है? मैं rudimentary क्यों बोल रहा है?
Because it's simply measuring the like literally a percentage of words coming from the original text.
No, not original. वही मुझे पहले लगा था, बट इसमें वो बोल रहा है कि वो ओरिजिनल को समरी से नहीं कंपेयर कर रहा है, रेफरेंस समरी को जनरेटेड समरी से कंपेयर कर रहा है. सो दिस इज सॉर्ट ऑफ सुपरवाइज्ड लर्निंग.
ठीक है, बेसिकली you have a data set where you have text and summary.
Correct.
And then you are generating a summary based on original text and you're comparing it with the reference summary,
Correct.
right?
Right.
Now, the reference summary may have different vocabulary altogether. Like by vocabulary, I mean different words altogether from the original, right? And at least till now, what NLP generation models we have seen, the generation of new vocabulary based on original text is not very common. I mean, you do have generation which is happening, but not to that extent, which you see in LLMs. Like we saw with the Shakespeare, काफी gibberish type का generation है. So I don't know if this is needed so much, given LLMs generate great summaries, which may or may not look like human generated summaries, but will probably be way better in summarizing the original text than a human is.
No, but this is the training part ना. What you are talking about कि LLM generate करता है, वो तो trained model का aspect बता रहा है. But to get to that, how do you train it to be that good? Right? And this is not a causal language model. So this is not a generative language model. Both of them involve transformer architecture, but this is a different type of a language model, right? Which is summarizing.
Model can be whatever. I'm saying the evaluation metric Rouge is kind of not needed so much anymore.
Why not? I don't get that. Right, causal जैसे GPT को ही मैं ट्रेन कर रहा था, उसमें भी तो ट्रेनिंग में रेफरेंस ये था, नेक्स्ट वर्ड था, है ना? उसकी ट्रेनिंग कैसे होती है? उसका भी तो लॉस फंक्शन चाहिए, उसको भी तो सिखाना चाहिए कि क्या सही है क्या गलत है, राइट? और उसके केस में स्पेसिफिक रेफरेंस आंसर नहीं था, बट नेक्स्ट वर्ड इटसेल्फ वुड डबल अप एज द टारगेट वेरिएबल, और उससे तुम उसको निकालते थे. तो वो देख के वो अंडरलाइंग प्रोबेबिलिटी डिस्ट्रीब्यूशन उस लैंग्वेज का और एटलीस्ट उस डेटा सेट का वो सीख जाता है. तो अगर मैं इंग्लिश छोड़ दूँ, अगर मैं सिर्फ उसको पाइथन कोड पे सिखाऊँ, तो वो पाइथन कोड जनरेट करने लगेगा. सो दैट्स द जनरेटिव GPT-2 वाला पार्ट. लेकिन मैं अगर समरी में मैं उस पर तो रिलाई नहीं कर सकता नेक्स्ट वर्ड वाले पे, तो और ये कम्प्लीटली डिफरेंट टास्क वाला एक मॉडल में ट्रेन करने की कोशिश. इसका एक और अलग कॉर्पस हो सकता है जो कि इसके केस में है. तो इसको मैं रेफरेंस क्या दूंगा? तो मुझे तो रेफरेंस देना ही पड़ेगा ना. तुम ये भले ही अगर तुम ये कहना चाह रहे हो कि हाँ मैं एक और ट्रिक ये करता हूँ कि मुझे एक को क्योंकि मैं एक फाइन ट्यून करना चाहता हूँ मॉडल और मेरे पास बना बनाया डेटा सेट नहीं है और मुझे खुद से एक डेटा सेट बनाना है और मेरे पास उतनी ह्यूमन कैपेसिटी नहीं है कि मैं एक ह्यूमन को बोलूँ कि इसकी समरी जनरेट करे, तो मैं किसी एक एग्जिस्टिंग मॉडल का मदद लेके वो रेफरेंस ये बता रहा हूँ, दैट्स अ डिफरेंट थिंग. बट इफ यू आर सेइंग कि रेफरेंस लेबल की ही जरूरत नहीं है, इज दैट व्हाट यू आर सेइंग?
नहीं, I am saying that this metric called Rouge is, what does the metric say? It says how good your summary is.
Compared to my what I believe is the right summary.
Yes.
Yeah.
Now, this was made for a world where the text generation was almost like meaningless, like gibberish, right? And the transformer architecture changed that nature of generation completely. And I say this coming from like having worked on NLP problems before, and even with hundreds of thousands of summaries available, what we were able to generate was really poor in terms of grammar, using original, so to speak, original or prior NLP models. But once GPT came in, the quality of generation improved so dramatically that all these root scores and all, I don't think they matter anymore.
So
It's
what
like
does then? What do you think does? Do you think we should just Google what? Is there any replacement for Rouge essay?
Yeah, I'm sure there are many other eval metrics which are now there for LLMs. So it's like तुम
No, for
measure कर रहे हो
this
कि
thing though. Like your LLM तो एक हो गया. That's a very broad umbrella,
yeah,
right? But within this NLP task, हर टास्क का इवेल्यूएशन मेट्रिक सेम नहीं होगा ना. सो इन दिस केस जो समराइजेशन है, लाइक यू आर सेइंग, आई एट अ हाई लेवल व्हाट आई थिंक व्हाट यू आर सेइंग इज कि जैसे ये रेफरेंस समरी थी और ये उसकी जनरेटेड समरी है. आई थिंक व्हाट आई अंडरस्टैंड फ्रॉम व्हाट यू आर सेइंग इज रेफरेंस समरी की उन टाइम पे ज़रूरत थी जब ये एक ह्यूमन को लिखना पड़ता था, उनका जनरेटेड टेक्स्ट अच्छा नहीं था. अभी यू आर सेइंग कि वो जनरेटेड उतना अच्छा बनाता है कि आई लव्ड की जगह पे आई वाज व्हाट एक्सटैटिक और कोई ऐसा शब्द डालेगा जो इसने रेफरेंस में नहीं डाला था, इसलिए इसका स्कोर अच्छा नहीं आएगा. हालांकि अच्छा जनरेटेड समरी था, जस्ट दैट ह्यूमन ने उसको एक्सटैटिक में उसने एक दूसरे टाइप का शब्द यूज किया, इसलिए दो शब्दों का मिसमैच हुआ, इसलिए स्कोर कम आया. इज दैट व्हाट यू आर सेइंग?
नहीं, आई एम जस्ट सेइंग कि स्कोर कितना भी आए वो मीनिंगलेस है अभी, बिकॉज द स्कोर वाज फॉर मॉडल्स व्हिच वर गिविंग आउट टेक्स्ट in a very different manner, in the manner that we have seen, right? Right now with GPT, the way we produce text is very different. So I don't know if this Rouge metric is really relevant anymore.
Okay.
That's all I'm saying. So I don't know if we need to get in depth into it. It's like saying कि your problem was going from place A to place B, and you were doing like horse. You were going by horse, and you were measuring the heartbeat of the horse, and you were measuring the gait of the horse and everything. And suddenly now you have a car to go from A to B. Then you don't need to measure heartbeat or gait or whatever. You just have a completely new
I
paradigm.
don't think that is the case though. Irrespective whether you were going with going from horse or cart, what you're measuring is not एक means. What you're measuring is the efficiency. How fast did you go? Like did you take 5, 10? What was your carbon footprint? What was it? So these are generic metric against which you will find out whether that mode of transport was good or not. It may be good on some aspects, it may be bad on some aspects. But the criteria to evaluate, irrespective of whether now there are cars which take you faster, दैट्स फाइन, बट मेट्रिक विल शो ये दे, मतलब ट्रांसफॉर्मर आर्किटेक्चर की वजह से अगर समरी बहुत अच्छा प्रोड्यूस होती है आज के डेट में, और जो पहले के मॉडलों में नहीं होती, बहुत अच्छी बात है, स्कोर अच्छा आएगा. बट दिस इज अबाउट द मेट्रिक इटसेल्फ. व्हाट डज मेट्रिक मेजर? मेट्रिक मेजर्स की मैं जो चाहता हूं सही वाला और तुम जो चाहते हो, दोनों में फर्क आ रहा है क्या नहीं, वो मैं सिर्फ मेट्रिक की बात कर रहा हूं. मेट्रिक की ही जरूरत नहीं है ऐसा क्यों बोल रहा है वो मुझे समझ में नहीं आया. हाँ, हो सकता है अभी जनरेटेड समरी अच्छी आ रही हो, दैट आई अंडरस्टैंड, बिकॉज आर्किटेक्चर चेंजेस, हॉर्स से लेके तुम कार में चले गए. जो पहले टिपिकली ये समराइजेशन के प्रॉब्लम बहुत अच्छे नहीं होते थे, अभी बहुत अच्छे आ रहे हैं क्योंकि स्केल बढ़ गया, $1 बिलियन, और वो जनरली सारे ही टास्क में है, नॉट जस्ट समराइजेशन, सारे टास्क. तो बाय दैट काउंट आई गेस यू आर राइट कि वो जनरेटेड समरी अब अच्छी आएगी. बट जनरेटेड अच्छी भी आएगी, नहीं बुरी आएगी, बोलने के लिए भी तो कोई मेट्रिक चाहिए ना, वरना तो फिर परसेप्टिव बस ये सब्जेक्टिव है.
हाँ, and that metric need not be Rouge because it's a very simplistic metric. It is just looking at n-gram sequences, right?
एनग्राम का उसका ये था, इसलिए उसने फिर वो दूसरा भी बोला ना, एलसीएस वाला बोला, जिसमें तुम लिस्ट कॉमन सब सीक्वेंस देखते हो. हाँ, इन अ सेंस इट इज स्टिल ये, मतलब एनग्राम की तरह वो ये हार्ड ऑर्थोडॉक्स नहीं है कि हाँ ये दो शब्द एक साथ आए, क्या नहीं आए तो फट गया, ऐसा नहीं है. तो वो फिर देखता है कि सीक्वेंस में कहीं भी आ रहे क्या. बट टू योर पॉइंट, हाँ, कि थोड़े शब्द बदल गए तो फिर हो सकता है स्कोर उसका कम आए. बट देन यू ऑल्सो प्रोवाइड मे बी a list of reference summaries, not just one reference summary, and list of reference summaries, and you take the maximum out of this. But otherwise I don't see a good means of comparing this subjective ये होता है कि what is a good summary at the end of the day. How would you even attempt to score that which one is a good? It's a very subjective things ना.
Yeah, I'm sure उस पे बहुत research है, and like you have like semantic comparisons whether the word or the meaning of this summary is same as human generated summary or whatever. तो वो meaning level पे जो summarization के evaluation metrics होंगे, they might be more meaningful than this kind of.
too much ये इसमें फंसे,
हाँ.
फाइनल ये करते हो छोड़ देते.
Point I was trying to make was हमको इस पे ज़्यादा ध्यान नहीं देना चाहिए.
हाँ, एग्जैक्टली. फॉर समराइजिंग अब इतना डिस्कस किया है तो एक बार ये करके खत्म कर लेते. हालांकि आई लाइक दिस बेटर एंड गो टू गूगल समराइजेशन मॉडल्स. what evaluation criteria क्या था वो?
क्या?
What are the popular evaluation metric?
Especially given LLMs.
Given what? Given the rise of LLMs?
Given rise of LLMs. G-eval. सब कंबाइन करके यूज कर लेते हैं. अब है तो यूज करो टाइप्स.
ठीक है, इस पे आगे बढ़े.
हाँ.
लेट्स डू, इसका कोड ओपन करते हैं. ये क्यों चाहिए किट? पता नहीं, बट देखते हैं। पुश करना है तो ज़रूरत होगी, पुश तो नहीं करना है मुझे। ये समराइजेशन है ना। So you have an English data set, you've seen samples. इसका इसमें रेफरेंस समरी तो नहीं दिख रही है मुझे, या कहीं और से लाता है। रिव्यू आईडी और ये टाइटल और बॉडी प्रिंट किया, पार्टनर्स में काम करेगा बोला, ट्रेनिंग में ही ये डेटा फ्रेम में लेके आया, कैटेगरी वैल्यू काउंट्स 20 ब्ला ब्ला ब्ला। फिल्टर बुक्स, preparing multilingual corpus. Training a summarization model on for like previous would take far too long. A single focus on generating summaries for a single domain of products. Okay. The most popular product in English database about 1,000 including to stay within the team. Filter किया कम करने के लिए process. Then apply filter function and sanity check if less blah blah blah. You can see the reviews are not strictly about books and might refer to things like Before we look at various models that are suitable for this task, we have one last bit of data preparation to do, combining. अच्छा, तो ये बाइलिंगुअल बना रहा है, इसलिए दोनों डेटा सेट लेके आया और कॉन्कैटिनेट किया। Each split concatenates a split shuffle reason blah blah blah. This certainly looks like a mix of English and Spanish reviews. Now that we have training corpus, one final check is the distribution of words in the reviews. Short reference summarizing the शॉर्ट समरी वाले उसने हटाए, राइट। अभी उसके पास इतने सारे ऑप्शंस हैं कि मैं कौन सा मॉडल यूज़ करूं, क्योंकि दिस इज़ अबाउट फाइन ट्यूनिंग। ये भी सही है। तो एनकोडर डिकोडर मॉडल की जगह पे उसने सिर्फ डिकोडर मॉडल यूज़ किया और बोला TLDR। This is a pre-training objective to predict access universe, so transform architecture that from its own does in text today. text format. MT, 50 languages, 101 languages, MT5. Now what else? With both encoded step. ये masked वाला चीज़ है अगर it combine. So T5 is a what kind of a model?
Summarization, text to text.
So it's a encoder decoder both.
That I don't know.
Yeah, just encoder names. इसको पूछ लेते हैं quick. Is T5 an encoder decoder model? Yes, encoder. Okay. Translate English to German. This is good. Das ist good. Call a sentence. The course is jumping well. Not acceptable. Summarize. 6 people hospitalized. So it is saying it will focus on M5. The interesting architecture based on M5 that was pre-trained. In T5, every NLP task is formulated in terms of a prompt prefix. So prompt prefix दे दो तो वो अच्छा करता है. ठीक है. MT5 don't use prefixes but shares much of the versatility with T5 and has the advantage of being multilingual. Now that we have picked a model, let's take a ये. तो ये T5 का था but अपन pick कर रहे हैं MT5, right? Just see next task is tokenizer encoder reviews and their titles. As usual, we'll begin by loading the tokenizer associated with the pre-trained model. तो MT5 small लिया, उसका tokenizer लिया, उसका tokenize किया. Here we can see family input and attention mask. अंदर no क्या था वो token IDs or something. वो नहीं था. Are encountered in the. Let's decode this. I love reading. Space based blah blah blah. Yeah. A special Unicode character indicate that we're dealing with sentence piece tokenizer. What does this mean? ये अपन ने कुछ ऐसा पढ़ा था क्या?
हाँ, सेंटेंस पीस लास्ट इसमें देखा था ना हमने, yesterday or day before yesterday. वर्ड पीस, सेंटेंस पीस.
वर्ड पीस BP था एंड यूनिग्राम था ना.
हाँ.
वर्ड पीस, यूनिग्राम एंड BP.
Sentence piece was like a sort of advanced version of word piece. They were looking at sentences. We didn't like dig into it exactly.
Okay.
But it was just an extension of word piece. वो एक लाइन उसने बोला था यार, उसको याद नहीं क्या exactly.
Okay. But sentence piece apparently uses underscore, so that's why this. मतलब अगर hash वगैरह use किया होता then we would have said word piece, I guess. Anyway. So Unigram is especially, but it is based on Unigram segmentation. Unigram is especially useful for multilingual corporations that allow sentences to be agnostic about accents, punctuation, and the fact that so okay. Again, I don't know why Unigram only specifically is agnostic about accents and not others. To tokenize our corpus, we have to deal with subtlety associated with summarization because our labels are also text. It is possible that they exceed models maximum context, and this means we need to apply truncation to both the reviews and the title. So title is the summary, kya?
क्या
Title is the summary. I did not realize that.
हाँ,
Summary मुझे दिख ही नहीं रही है. This means we need to apply truncation to both reviews and their titles. The tokenizer in the Hugging Face transformer provide a nifty text target argument. Tokenizer in parallel to this. Okay. So you have model inputs and you have labels. The first thing we've done is define max input length and max target width. Metric for text summarization. Just provide this. You say compute. There's this. Very strong baseline. तूने एनएलपी का कौन सा यही किया था क्या? समराइजेशन पे काम किया था?
हाँ,
यही लाइब्रेरी यूज करती है ये बहुत बार देखी है मैंने. ठीक है.
I don't think I looked at the code as much as the output.
This is what pre-transformers. Yeah, post-transformers.
हाँ,
Common baseline for text summarization is to simply so creating a strong baseline, right? What is it saying now? As common baseline for text summarization is to simply take the first three sentences of the archetypal, often called the lead three baseline. We could use full stops to track sentence boundaries, but this will fail on acronyms. So instead we use analytical library, which includes a pattern algorithm to handle this crisis. You can install package blah blah blah. Analytica download 3-sentence summary. So I grew up reading Kunz, and years ago I stopped and still she forgets, she wants strangers. Okay, तो इसने बस text का 3 sentence दे दिया. This seems to work. So let's now implement a function that extracts summaries from a dataset and computes the Rouge score for the baseline. Evaluate baselines. So for samples in the data set, take out its summary based on 3-sentence summary, and then compute the Rouge score, where you have the reference title and this. We can then use this function to compute the root or the validation set and prettify them a bit using pandas. ठीक है, जो भी आया इसका 16.8 डालिए. We can see that the Rouge 2 score is significantly lower than the rest. This likely reflects the fact that the review titles are typically concise, and so the lead 3 baseline is too verbose. Towards fine tuning. Alright, so here we have just made sure that I think the benchmark works. Right, without training, if you just take first 3 sentences आ रही है तो उसका root score you see that not that great. So then you go to fine tuning. Model checkpoint T5 का है तो right model आ जाएगा, and then you do the typical ये. These are what about hyperparameters क्या? Your batch size blah blah blah. This is the training वाला trainer object. ये था क्या? ये क्या? This should be the hyperparameters, right? Let's first define the hyperparameters and other arguments for our. तो इस मॉडल के जो भी hyperparameters थे वो fully तुमने यहाँ दिए. Here predict with generate argument. Predict with generate. ये argument किधर है भाई? Been set to indicate that we should generate summaries during evaluation so that we can compute root score. Okay, so root score is only during evaluation, which is fair. As discussed, the decoder performs inference by predicting token generate function. Setting predict with generate equal to true tells us that we use the method for evaluation. We have also adjusted some of the default hyperparameters. We have a small version of the directory push to it. This is fine. The next thing we need to do is to provide a trainer with compute metric function so that we can evaluate the model. This one is a bit more involved than simply calling compute of the model, since we need to decode the outputs and label into. So we need to decode the outputs and labels into text before we can compute root score. Okay. So output तेरे logits आएंगे तो वो तुम्हें decode करके इसको देना है क्योंकि उसको तो text चाहिए. So it is the following function does exactly that. Also makes send tokens function from analytical to separate summary centers and new line. Send tokenize. So you have a compute metric, right? Yeah. Compute metric. ओके, ये दोनों एक साथ आता है, उसको प्रेडिक्शन और लेबल्स. डिकोडेड लेबल्स और फिर तुमने दोनों को डिकोडेड प्रेड्स एंड डिकोडेड लेबल्स होपफुली ये फिर टेक्स्ट है. Then you provide this to this and extract a score. This is required because only sees previous. ये समझा क्या कि इसको डिकोडर मॉडल है तो उसको लेबल्स को राइट बाय वन वो बोल रहा है कि करना पड़ेगा. So it says since MT5 is an encoder decoder transformer model, one subtlety with preparing our batches is that during decoding we need to shift the labels to the right by one. This is required to ensure decoder only sees the previous ground truth label and not the current or future ones, which would be easy for memory, right? This is similar to how mask self attention is applied, right? So decoder model में अपन पीछे वाला नहीं देखेंगे वो ठीक है, बट ये किया क्या है और क्यों है. कहाँ गया भाई, गायब हो गया था क्या?
पता नहीं, मेरा मीट ऐप क्रैश हो गया.
अच्छा, कब से नहीं था तू?
I wasn't able to join back. I kept trying to disconnected, reconnected. समझ में नहीं आया क्या हुआ.
Okay. मैं बस कोड ही ये कर रहा था और I was just stumped on this particular line, which says since MT5 is an encoder decoder transform model, one subtlety with preparing our batches is that during decoding we need to shift the labels to the right by one. This is required to ensure that the decoder only sees the previous ground truth labels and not the current ones, just as in self attention. तो self attention decoder model में अपन पिछले वाला आगे वाला नहीं देखते वगैरह, that's fine, but यहाँ पे वो कौन से लेबल शिफ्ट कर रहा है मेरे को एग्जैक्टली नहीं समझा. So it says data collector for sequence to sequence, tokenizer दे दो, model दे दो. Let's see what this collator produces when fed a small batch of examples. First we need to remove this is tokenized data set. First you need to remove the columns with strings because the collator won't know how to pad these elements. Accelerate वगैरह तो छोड़ दो, ट्रेनिंग लूप. ये थोड़ा बहुत तो स्टैंडर्ड लग रहा है, बाकी कुछ कुछ चीज़ें नहीं समझी मुझे. एक्सेलरेट छोड़ देते हैं. यहाँ पे वो क्या कर रहा था, वो एक चीज़ है. Stop streaming.
क्या हो गया?
वो करके देख रहा था, कोड देखने के लिए वो फट रहा है. आई डोंट नो कि एक्सेस टोकन का प्रॉब्लम है क्या.
अच्छा.
उसका तो नहीं था वो प्रॉब्लम. क्यों फट रहा है फिर पता नहीं, एक एरर आ रहा है. pip install datasets तो है ना. नहीं था शायद. ठीक है. Really? The data set Amazon Review Multi is defunct and no longer accessible due to decision of the data. ठीक, तो ये तो नहीं हो पाएगा. So you have to work through the documentation only लगता है. But again, I think this is too much into the weeds. कि
हाँ, घुसने की जरूरत नहीं है.
वही मैं कह रहा था कि वो एक्चुअली सारे ही वैसे ही है. एक्चुअल फाइन ट्यूनिंग कैसे करना है, एंड देन देयर आर टास्क स्पेसिफिक जो नुस्खे हैं I don't think
Ah.
it will help us gain any more. Like, of course, anything that you read will gain something. But yeah,
सिग्निफिकेंट गेन नहीं
हाँ
होगा.
वही मैं कह रहा था कि वो कुछ खास ऐसा हर एक के जाने से अपना टाइम ही वेस्ट होगा. वेस्ट नहीं होगा, अगेन यू नो व्हाट आई मीन. लेट्स सी, ये देख लेते हैं.
In a lot of our examples, you're going to see data collators popping up over and over. They're used in both the PyTorch and the TensorFlow workflows, and maybe even in JAX, but no one really knows what's happening in JAX. We do have a research team working on it though, so maybe they'll tell us soon. But coming back on topic, what are data collators? Data collators collate data. That's not that helpful, but to be more specific, they put together a list of samples into a single training mini batch. For some tasks, the data collator can be very straightforward. For example, when you're doing sequence classification, all you really need from your data collator is that it pads your samples to the same length and concatenates them into a single tensor. But for other workflows, data collators can be quite complex as they handle some of the pre-processing needed for that particular task. So when you want to use a data collator, for PyTorch users, you usually pass the data collator to your trainer object. In TensorFlow, it's a bit different. The easiest way to use a data collator is to pass it to the toTFDataset method of your dataset. And this will give you a TensorFlow tfdata.dataset that you can then pass to model.fit. You'll see these approaches used in the examples and notebooks throughout this course. Also note that all of our collators take a return tensors argument. You can set this to PT to get PyTorch tensors, TF to get TensorFlow tensors, or NP to get NumPy arrays. For backward compatibility reasons, the default value is PT, so PyTorch users don't even have to set this argument most of the time, and so as a result they're often totally unaware that this argument even exists. We can learn something from this, which is that the beneficiaries of privilege are often the ones most blind to its existence. But okay, coming back, let's see how some specific data collators work in action. Although again, remember, if none of the built-in data collators do what you need, you can always write your own, and they're often quite short. So first we'll see the basic data collators. These are default data collator and data collator with padding. These are the ones you should use if your labels are straightforward and your data doesn't need any special processing before being ready for training. Note that because different models have different padding tokens, data collator with padding will need your model's tokenizer so it knows how to pad sequences properly. The default data collator doesn't need a tokenizer to work, but it will as a result throw an error unless all of your sequences are the same length, so you should be aware of that. Moving on though, a lot of the other data collators aside from the basic two they're usually designed to handle one specific task. And so I'm going to show you a couple here. These are data collator for token classification and data collator for seek-to-seek. And the reason these tasks need special collators is because their labels are variable in length. In token classification, there's one label for each token, and so the length of the labels is the length of the sequence. While in seek-to-seek, the labels are a sequence of tokens that can be variable length that can be very different from the length of the input sequence. So in both of these cases, we handle collating that batch by padding the labels as well, as you can see here in this example. So inputs and labels will need to be padded if we want to join samples of variable length into the same mini batch. That's always the case across all data collators, and that's exactly what these data collators will do for us in for these particular tasks. So there's one final data collator I want to show you as well, just in this lecture, and that's the data collator for language modeling. So it's very important, and it's firstly because language models are just so foundational to do for everything we do with NLP these days. But secondly, because it has two modes that do two very different things. So you choose which mode you want with the MLM argument. Set it to true for masked language modeling, and set it to false for causal language modeling. So collating data for causal language modeling is actually quite straightforward. The model is just making predictions for what token comes next, And so your labels are more or less just a copy of your inputs, and the collator will handle that and ensure that the inputs and labels are padded correctly. When you set MLM to true, though, you get quite different behavior that's different from any other data collator. And that's because setting MLM to true means masked language modeling, and that means the labels need to be, the inputs need to be masked. So what does that look like? So recall that in masked language modeling, the model is not predicting the next word. Instead, we randomly mask out some tokens, and the model predicts all of them at once. It tries to kind of fill in the blanks for those masked tokens. But the process of random masking is surprisingly complex. If we follow the protocol from the original BERT paper, we need to replace some tokens with a mask token, some other tokens with a random token, and then we keep a third set of tokens unchanged. This is not the lecture to go into the specifics of that or why we do it. You can always check out the original BERT paper if you're curious. It's well written, it's easy to understand. The main thing to know here is that it can be a real pain and quite complex to implement that yourself, but the data collator for language modeling will do it for you when you set MLM to true. And that's an example of the more intricate pre-processing that some of our data collators do. And that's it. So this covers the most commonly used data collators and the tasks they're used for. And hopefully now you'll know when to use data collators and which one to choose when you have for your specific task.
टेक्स्ट जनरेशन टास्क में वो बातें चल रही है उसकी ये देखना है अपने को कि आगे क्या
So, just to recap, like he said that there are, or at least this text said that there are various fine-tuning approaches. Have we seen them? I don't kind of recall different approaches. It was always कि एक line of code में तुमने उसको करवा दिया, right?
there are following एक और है आगे, but एक तो उसका कहाँ पे वो बोला है डिफरेंट, ये क्या
यहीं पे उसने कहीं बोला, अभी जो टेक्स्ट दिखा हमने,
ये वाला ये
हाँ.
I think what is saying is this, like all these were like fine tuning existing models, right? To that point, however, कि ट्रांसफर एक अलग से लार्ज लैंग्वेज मॉडल के लिए फाइन ट्यूनिंग का अलग से एक और भी है जिसमें एसएफटी ट्रेनर वगैरह है, बट अंटिल नाउ जो हमने फाइन ट्यूनिंग देखी है दैट इज बेस्ड ऑन द सेम प्रिंसिपल जो अपन एक्चुअल फाइन ट्यूनिंग का एक लेसन जो कर चुके थे, जो अपन ने एक्चुअल कोड भी रन किया था इसमें, और ये एनएलपी स्पेसिफिक टास्क में मुझे और कोई फर्क नहीं दिखा, क्योंकि वो भी बेसिकली ट्रेनर एपीआई या जो कॉन्स्टेंट लूप है वो फिर एक्सेलरेट के साथ तो बस स्पीड अप करने के लिए है, बट वो जो एक तरीका था इधर यूजिंग ट्रेनर एपीआई और रनिंग योर ओन लूप और उसको फाइन ट्यून करना एक एग्जिस्टिंग मॉडल लेके, जो अपन ने इस लेसन में सीखा था, इनमें एटलीस्ट हाई लेवल पे देख के तो मुझे सारे वैसे ही लगे। फाइन ट्यूनिंग करने का तरीका सब में ट्रेनर एपीआई ही यूज़ किया गया। जैसे अपन ने अभी समराइजेशन देखा है ना, तो समराइजेशन में इफ़ यू सी नहीं फाइनली इसमें लास्ट में भी किया है वैसे यहाँ पे भी. हाँ, ये वो लूप था जो अपन ने ट्रेनर एपीआई में चलाया था, राइट. मॉडल डॉट ट्रेन में डालना, इवेल्युएशन में उसको इवेल्युएट करना, और ये इपॉक के टाइम पे चलाते रहना, बैकवर्ड क्लॉज ये करना, प्रोग्रेस बार दिखाना ताकि तुम्हें विजुअली ये चीज़ दिखती रहे. ये जो चीज़ अपन ने की थी, राइट. समराइजेशन में तो एग्जैक्टली कम से कम वही फाइन ट्यूनिंग थी जो अपन ने पहले की थी. ऑफ कोर्स इवैल्यूएशन के लिए उसका मेट्रिक अलग था, डेटा सेट प्रिपेयर करने का, डेटा कोलेशन का ये अलग था, बट ऑन हाई लेवल ट्रेनिंग का जो पार्ट है वो सेम है. या तो आप ऐसे ट्रेनिंग लूप में कर सकते हो, या इसको सब एब्स्ट्रैक्ट आउट करके, क्योंकि बहुत सारे चांसेस है आप मिस कर दो, ऑप्टिमाइजर गलत डाल दो, उसका ये गलत डाल दो, तो ट्रेनर एपीआई यूज़ कर दो, और भी सिंपल है वो बोल रहा है. तो ट्रेनर एपीआई यूज़ करके तो और भी सिंपल तरीके से हो जाता है. बट हाँ, वो दो तरीके हैं. अभी इसके बाहर या तो दूसरा तरीका ये है, ट्रेनर डॉट ट्रेन बोल दो और हो गया काम, और इसको बोल दो ट्रेनर डॉट इवैल्यूएट, तो फाइनल रिजल्ट बताएगा, और फिर ट्रेनर को पुश कर दो, राइट. वर्सेस डूइंग दिस. सो ईदर वे, but yeah, I don't think we have gone through any other way of any other approach of to fine tuning, and hopefully we'll cover that in here. Chapter 2 section 2, visual general can be fine tuned in a specific like summarization. However, nowadays it is far more common to fine tune language model on a broad range of tasks simultaneously, right. वो specific task के लिए fine tuning था.
हाँ.
तो मेथड नोन एज सुपरवाइज्ड फाइन ट्यूनिंग, ये कोई एक एक्सक्लूसिव एक अलग टॉपिक है विच आई थिंक विल होपफुली कवर. दिस प्रोसेस हेल्प्स मॉडल बिकम्स मोर वर्सटाइल एंड कैपेबल ऑफ हैंडलिंग डाइवर्स यूज केसेस. तो इसका एंड ऑफ क्विज लेना है. हालांकि हमने बहुत सारा स्किप किया है, तो अगर उसका कोई स्पेसिफिक ऐसा क्वेश्चन होगा तो वी मे नॉट, बट लेट्स टेक अ शॉट.
Guess मार सकते.
Which of the following tasks can be framed as a token classification problem? Find the grammatical components in a sentence. I think so. Find the persons mentioned. Find the sentence is grammatically correct or not. Find the chunk of words in a sentence and answer. तुझे और कोई लग रहा है?
नहीं, I think ये दो, ये maybe the last one, but not sure.
Let's see. What part of the pre-processing for token classification differs from other pre-processing pipelines? There is no need to do anything. Texts are already tokenized. The texts are given as words, so we only need to apply subword tokenization. I think the second one. You didn't select all of them. We use -100 label to special. We need to make sure to truncate or pad labels with the same size inputs when applying truncating padding. Yeah, I don't know. Yeah, we need to make sure to truncate our labels. Same size inputs when applying. What problem arises when we tokenize the words in token classification problem and want to label the tokens? ये हो सकता है ना, tokenizer add special tokens and we don't have labels for them. Each word can produce several tokens, so we end up with more tokens than we have labels. The additional tokens, the added tokens are no longer. I don't know. Let's see. We label this -100. Okay, special tokens को -100 डाल देते हैं. सेकंड डाल देंगे और क्या. don't know, what does domain adaptation mean? It is when we run a model on a data set and get the predictions for each sample in that. Sounds like an inference, right? It's when we train a model on a data. It could be domain adaptation if it is training.
Fine tune. Yeah?
When we find in a predetermined new test and get a prediction.
And last one also, I don't know if we saw any examples of this, but intuitively sounds correct.
The labels in a masked language modeling problem. Some of the problems एक ही है, right? Each of these tasks can be seen as sequence to sequence. Translating from Chinese to Chinese English.
First one also.
Editing a short reviews. Fixing the messages and mail. This should also be na.
Technically, all of them.
Question
Answer
answering.
questions is also sequence to sequence.
What is the proper way to pre-process the data? For sequence to sequence problems, the input and targets have to be sent together to the tokenizer with the inputs. क्या है इसका आंसर?
I think second one. Last one. Special context manager. ये क्या है?
उसी में था क्या? Sequence to sequence translation में बोला हुआ उसने. Why is there a specific subclass of trainer? Sequence to sequence problems. अम्मा कसम. क्या ही आंसर है भाई इसका? स्पेशल इवैल्यूएशन. When should you pre-train a new model? And there is no pre-trained model available. And you have lots of data available, even if there is a pre. I don't know. And the pre-trained model available are just not good enough. So I think he's suggesting कि हम उसको fine tune करें. Why is it easy to pre-train a language model? Lots and lots of text. क्यों भाई? ट्रांसफर, मुझे लगा वो अपना बड़ा ही ये करेगा कि हमारा कोड तो बहुत कम है, यूज करो तुम बड़ा सा टेक्स्ट तो what are the main challenges when pre-processing data for question answering task?
चैलेंज क्या है? I don't know. करना तो सब कुछ ही है टोकनाइज में.
From the answers paired in the text, you need to find the start and end token in the token as input, or you need to deal with the very long text context which gives several training features. I don't know, मुझे तो इन दोनों में से कुछ तो एक लग रहा है. तुम क्या बोलते हो?
Or a change. You're right.
How is post-processing usually done in question answering?
लास्ट वाला ही है ना?
The model just gives you the start and end position answer for each feature created by one example, and then you just have to decode the corresponding span of tokens in the one that has the best score. Or the model gives you the start and end position of the answer for each feature created by one example, and you just have to match them to the span in the context. So तुम्हें जो टोकन जो स्टार्ट एंड एंड पोजीशन मिला वो टोकन है, तो तुम्हें बस डिकोड ही करना है, राइट, या मैच करना है. ठीक है. What do you do when you get an error वगैरह वो सब ठीक है. जब when actually developing something, building and sharing demos, ये अपन चाहिए तो क्विकली कर सकते हैं, बट डोंट थिंक दिस इज.
ये काहे का डेमो है?
ये हगिंग फेस पे ग्रेडियो से तुम ऐप बिल्ड करके डेमो कैसे दे सकते हो और एप्लीकेशन अपना शेयर कैसे कर सकते हो. अभी तक अपन ने डेटा साइट मॉडल ये सब शेयर किया, राइट. व्हाट इफ यू वांट टू बिल्ड एन ऐप where you say I have an image classifier and this is my model, here it is live, just upload your image and I will classify it, right. तो वो अगर ऐप बनाना है तो ग्रेडियो से बनाना है. it's a simple process. So if you go to Hugging Face, you go to Spaces, these are all apps, the AI app directory, right. You just let's go to this guy's app 4 days ago. प्रॉम्प्ट दो, कुछ थिंकिंग विंकिंग बताओ, कुछ करो, जनरेट करो, वो कुछ करेगा. तो उसने मॉडल ही पुश नहीं किया, उस मॉडल को यूज़ करके एक एप्लीकेशन बनाया और ये इसका UI इंटरफेस है. दैट इज डन यूजिंग ग्रेडियो. एंड यू जस्ट पुश just like you pushed your models and data sets and everything, tokenizer and everything, you also push your this. So if you have to just look at ideas, let's say image generation, Flux Pro Unlimited, chapa chapa chapa, enter Library of prompt. बताओ. Tiger eating grass. I don't know what it is. ये तो कुछ जनरेट हुआ भी नहीं क्या? चल रहा है. And if you see, बहुत घटिया डेमो था इसका. इसने तो बड़ा तामझाम किया है कुछ कुछ. And भाई डिटेक्टिव डॉग है. टाइगर ईटिंग ग्लास. So that's that. So this should be quick unless we have very specific demo. एक dummy hello world program बनाने के लिए तो easy है. Curate high quality data set. Again, since we wouldn't be, this also should be quick. And I think then we need to focus on the last two chapters, which I think is of some relevance. ये LoRa के बारे में बहुत सुना है मैंने. लो रैंक एडप्टेशन, particularly vision models में. Vision models में हाँ I think so. Okay, I think 11, 12. Hopefully 11 तो start करना चाहिए कल. ये तो quickly ख़त्म करके. ठीक है. खाने के सिवाय तो उसने सब कुछ दिखाया मुझे. कार्निवोर ऐसा कहा. अच्छा उसने स्टोरी लाइन वाला है ये. ओके, इसका ऐप अलग चीज़ के लिए बना है. Grass is not my go-to meal, but desperation calls for desperate measures. This might not be the best meal, but a bird in the hand is worth to ambush. I wonder if I would stagger the fish. But the next protein wouldn't hurt. A hunger in my belly is fueling my every move. I understand if that fish is mine. रात से वो जल्दी से फिश पे भी पहुंच गया भाई. ठीक है. सो यहाँ पे एक ऐप बनाएंगे लेकिन अपने ग्रुप का.
हाँ.
अच्छा वाला कोई एक लार्ज लैंग्वेज मॉडल या विजन वाला भी देख सकते हैं. विजन वाला हालांकि हमने कुछ ज़्यादा बड़ा सोचना नहीं है तो थोड़ा मुश्किल है. बट टेक्स्ट बेस्ड कुछ तो मॉडल एक उठा लेते हैं और फाइन ट्यून करके कुछ डाल देते हैं. मे बी वही वाला यूज़ करते हैं, सर्वम वाला. अगर इंडियन कॉन्टेक्स्ट में कुछ करना है तो एक ऐप